I want to see if I can get my hands on an expression for the area from 0 to 1 underneath the function 1 over square root of x. But I know that if I plug in x equals 0, this function is not defined there. So this is what is called an improper integral. The function is not defined at this bound. I want to think about what the graph looks like real quick. This is only defined when x is greater than 0. And at x equals 1, y is equal to 1. And also, if I compare it to 1 over x, this function is coming down to an asymptote of y equals 0, but not quite as quickly as 1 over x. So maybe it looks something like this. And then it comes to 0 more quickly as I move to the left. How should I say that? As I move from 1 to 0, the y values climb more slowly than for 1 over x. So the graph looks something like this. I'm looking for this area, and I'm not sure yet whether that's finite or infinite, so whether this integral converges or diverges. I know that I can treat this as x to the negative 1/2. And I also know that I can, instead of trying to evaluate this directly at 0, I can set this up where I go from a to 1, where a is bigger than 0, and then I'll find that area and take the limit as a goes to 0 from the right. So let's try that. So I add 1 to this, I get 1/2. When I divide by 1/2, I'm multiplying by 2. So this is telling me I've got 2 times, well, let me write down the limit again. Limit as a goes to 0 from the right, 2 times, and then I got the square root of 1 minus the square root of a. The square root of 1 is 1. As a goes to 0 from the right, this is the square root of numbers that are shrinking down to 0, so that whole value is shrinking down to 0. So what I'm getting is 2 times 1. So we would say that this area is finite and it's equal to 2. That seems kind of bizarre if you've never really thought about it, because it looks like it's going infinite. But I mean, if you analyze it closely, this area, you can prove that it cannot possibly be any bigger than 2, and it also cannot possibly be any smaller than 2. So it's equal to 2.